Hello, my name is Nathaniel Miller, and today I want to talk to you about my senior project, the Outbreak Detection Robot, or ODR. I've been working on it since January, and I'm really pleased with the results that have come from it, and I hope you enjoy watching this video and hearing more about it. So my motivation behind this project came from about 4 years ago. I watched a movie right when I was starting college, and it was called The Hurt Locker. And in the movie, they used a robot to disarm bombs, and they were a bomb disposal unit, I believe, during the Iraqi War. And I thought that was a really cool idea, and but I didn't want to do that because one, it's already been done, and two, it would be really hard to test in a classroom setting. So, I sat down, did some thinking, and I had a friend back in high school who joined the military, and not long after joining, we heard that he died, and it was really really tragic, and his family, and it was just really sad, you know, incident, but everybody always was wondering, kind of how it happened because nobody really ever knew how he died. And the only thing I really ever heard of it was possible gas exposure, that he had been exposed to something that was harmful. And I was like, if only something could go in front of him to detect that, so he wouldn't have to have breathed that in. And that's kind of where the gas detection robot came from. And then I started talking with my dad, and he started mentioning radiation. And I was like, that'd be perfect to go along with what I'm doing. So that's how the ODR robot kind of came to being, is the amalgamation of those two things, along with the mobile part of the robot, making it is what it is. So that's kind of what motivated me to make this project.
Yeah.
So to start the breakdown, I'd first like to talk about the fact that I completely designed and fabricated all the parts, minus the electronics that are on this robot. Also, besides the tracks and the drive gear, I took that from another developer. But other than that, everything has been designed by me. And as far as the robot goes, not much has changed. The only changes I've made to it really was that there used to be shelves in there that would go in and out of it, and I decided not to use those because they just took up too much space and really didn't do what I wanted it to do. And then I also changed the top on it to the small. The hole was originally a little bit smaller than this, so the gas sensor would not fit, and then there was not a place to put the battery pack. So I added those two things. But the controller has seen a lot of changes. So originally this was the design, but I just did not like it because it was just way too big, too clunky, and just didn't utilize space very well. So I decided to switch to the smaller version, and but with when I was working with this controller, I also went through different variations of the faceplate. So this was the original one, but then it was too thick, so I decided to switch to a smaller one, which you can see here is so brittle and so thin that it couldn't even stay together. So that's really when I decided to kind of swap over to this one. And originally the faceplate that went on this was like this. However, the place where the joysticks go allow it to move anywhere. So I decided to change it to where this faceplate only allows this joystick to go up and down and this joystick to go left and right. So after doing that, this controller works perfectly in my opinion, and now allows for any phone to be used rather than my phone specifically, with the phone mount being added to the top of this controller.
So to break down how the ODR robot works, there are 4 parts to it that work in unison with one another. I'll start with and it's broken up into 2 sections. So I'm going to start with the gas detection portion of it. So the gas detector has a sensor on it that takes in a number value for the gas and sends it to the Arduino, which then sends it through the radio to the gas receiver. The gas receiver then translates that number and says, okay, if it's greater than this number, then it's hazardous. If it's lower, then it's safe. So if it is higher than that number, then it'll display a message saying hazardous. If it's lower than that number, then it's just going to display that number. As for the driving aspect, you have the controller that has 2 joysticks on it. Those 2 joysticks can one can be moved up and down, and the other can be moved left and right. Those joysticks have been mapped, so it sends an integer value through the Arduino through its radio transmitter to the actual robot. The robot then takes that number and says, okay, so for instance, if it's sent a 1, it moves forward. That means the left joystick has been moved in the forward position. Now, say you want to move, say, forward into the left. Okay, so the left joystick is moved forward, so that's a 1, and the right joystick is moved to the left, which is 4. So 1 plus 4 equals 5. So it sends a 5 to the robot, and then the robot's like, okay, 5, what is 5? Okay, 5 is, okay, 5 means to go forward and to the left. So that's how that works.
Okay, to quickly demonstrate real quick how the controller works. So our screen up here is giving our live feed from our robot, while this LCD screen down here is showing our gas value, so we know whether or not it's hazardous or not. Here's our joystick, so that'll control how our robot drives. So I'll show you how it drives real quick. So as so. So next we'll actually show you how it detects for gas as well as for radiation. So how we're going to test for the gas is, so I don't want to expose myself to a harmful gas, so we're going to use smoke instead. So what I'm going to do is I'm going to light these pieces of paper on fire and show them underneath this box. That's going to represent, you know, a fire in a room, just on a lot smaller scale. And then once the box is filled up with some smoke, then I'll drive my robot up close to it, and I'll show you on the remote that it says hazardous. Now we'll drive into the box as if we were driving into a room. Now if you look here on the remote, you can see that it is not quite enough smoke coming off of it to send out the hazardous signal, but it's very close to hazardous, displaying the 54,752. Now you can see the live stream video as it sees the smoke directly from the camera display.
Here's a short clip from my previous presentation of me demonstrating how the gas sensor shows a hazardous message once it has received enough smoke. This was a lot more concentrated, so it was a lot easier to demonstrate here rather than outside with the box, but the same thing still applies, as if enough smoke goes into the sensor that it will give off a hazardous message.
Okay, so also I can't just drive into an area where there's radiation at. So I bought a small bottle of uranium, and we'll hold it up close to the Geiger counter and let you listen for the click. So. Now this is low levels of radiation, so it's not going to go crazy, but you can see where it's clicking and the LED is lighting up. So I bought a safe amount, so it wouldn't be harmful to me, but I can still get some tests off of it.
One thing I haven't really talked about much in this video so far is the camera, and specifically the night vision portion of this camera is spectacular. I have this video of my hallway at 12 o'clock at night, pitch black, no lights on, and you can see perfectly with it. It is fantastic.
So when it comes to hardware projects, you face a lot of difficulties that you wouldn't normally face in just your typical computer science projects when you're just dealing with coding, because in hardware projects you could have a wire loose or something like that, and you wouldn't be able to know that that was the issue without going in and looking at it. When you're coding and that's all you're doing, all you have to do is look in the terminal, see what error it's giving you, and then go look for it. But some more specific challenges that I faced in this project as well. So I started the project by working on the gas detecting portion of the robot, and that's been the easiest part, I think, the project that I have done. But one issue I have with it is when it displays a hazardous message, it displays these weird symbols on the LCD screen after it says hazardous. So if I could get this to go away, that would be a huge success. The next thing too was the driver. I had a board that was working perfectly, and then once I added the code on it for the driving aspect, it ran out. It didn't have enough memory to run the program, so I had to buy a new board, new driver, and start from scratch there. But once I got that going, it worked perfectly. Another issue, just a small issue, was mapping the joysticks. That took a little while to figure that out. And then, as it is with probably most everybody's project, the coronavirus really did slow me down about a week or two. But not only that, but it made it very difficult to order parts that I needed, because the person I ordered, or the company that I ordered parts from, started making ventilators and stopped selling their hardware. So it really made it hard. I had to go look in small other areas to find the parts that I needed. And then another issue that I'm still facing is that I cannot disconnect my controller from my laptop. I think that has to do with it needs to output to a serial monitor to work. So without the serial monitor, it will not work. And then finally, it was the Geiger counter. I had coded it to work in unison with the Geiger, or with the gas sensor and output to the LCD screen. But once I did that, it fried my radio transmitter, and I'm not really too sure why it did that. I guess just too much power was probably too much. The voltage was going in too many directions. Could have been the problem with that. So I just decided to use the microphone on the camera instead, and let it pick up on the clicks, and then just let the user listen for the clicks on the cell phone. So those have been the main challenges of this project. But other than that, I think the project has gone very, very well.
So what I'm about to talk about here in the next portion of the video, in the future work section, is about what the military currently is using in terms of UGVs, unmanned ground vehicles. The remote that they use is called Roku 7, which has some similarities to what I have. It created. It has a large LCD screen in the center that shows a live video display, and has two joysticks on the side. Definitely more controls though than what mine has, but mine is still pretty close to what they're using, all things considered. And then they have multiple robots that they can use with it. The one I had in mind that probably works the best with what I've created and is kind of similar in size is called the Iris. So this Iris robot is, like I said, it's really small, so it can go anywhere, and I believe its uses mostly for intelligence, to help determine, listen in on conversations, maybe go places where people can't, and kind of look around, see, which is kind of a lot of what my robot does unintentionally with the camera, is it can see most everything that's going on, mostly for the driving aspect, so you can see where it's going, but it has a dual purpose in being able to listen in on conversations and see things that you might want to see as well. So that works right along with what Iris does. So all that would really need to be added is the gas sensor and a Geiger counter, and it'd be exactly what I've created. So I think that modular design, if they incorporated that into their Iris robot, I think it would almost be the exact robot that I've created. And I think it'd be really cool to see that one day.
So future work for this project, I would like to first fix the issues that I pointed out earlier in the video, and then next, so the project is already pretty modular, with the gas and radiation portion of the robot being separate from the driving portion, but I'd like to incorporate that modular design to what the military is already using, called the Roku 7, and make that modular design work with what the robot they have for their project, and then go from there. So I'm really happy with the results. Look forward to the advancements I can make in this project further, and I've learned a lot from this project. Thank you.